by alpha beta 1 2 glycosidic linkage, sucrose can be formed. Whereas when you see maltose, maltose is formed by combining of two glucose molecules, and the linkage is alpha 1 4. Whereas in the case of lactose, lactose is formed when one glucose molecule reacts with another galactose molecules. It will form lactose. And here, lactose is formed by beta galactose and glucose. The galactose should be in beta form. We have seen already alpha and beta form of glucose. They are anomers of each other. They differ only on the arrangement of OH at the carbonyl carbon. Disaccharides, all simple sugars or monosaccharides are reducing sugars. When you see disaccharides, when two simple sugars combine together by glycosidic linkage, and the disaccharide, if there is OH on the anomeric carbon is free, that form of disaccharides can be considered as reducing sugars. For example, when we see lactose, lactose is made by alpha 1 4 glucose linkage. Hence, the alpha OH of one glucose and the fourth OH, the fourth carbon OH group of another glucose molecules are involved for glycosidic linkage. Now, the second simple sugar has what? Free OH group at carbon or at carbon number 1. Then this molecule can be considered as reducing sugars. But when you see sucrose, as you know, sucrose is made from what? One glucose molecule and one fructose molecule. And fructose is a ketose sugar. The ketose sugar, when you see in the case of fructose, the carbonyl carbon is not found at carbon number 1. Rather, it is found at carbon number 2. The carbon of fructose OH linked with the OH at carbonyl carbon 1 of glucose. Then there is no free OH at on both glucose as well as fructose. And sucrose is considered as its non-reducing sugars. Now let's see one by one. Lactose, as you know, you are familiar with lactose, which is made by beta galactose and glucose, and sometimes called it's a milk sugar. It's common named as milk sugar, since it is found in milk and milk products. And its monomeric unit is galactose and glucose. Mind you, galactose should be in beta anomeric form. And what's the significance of lactose? It's useful as source of carbohydrate for infants. And galactose is useful for developing their brains as well. Digestion is started in the small intestine. Carbohydrate digestion in general is started in the mouth, whereas disaccharide digestion is started in the small intestine. Hence, enzymes are found on the brush border of small intestine, and like maltase, lactase, sucrase, and so on. If some individuals may feel uncomfortable once they drink milk, okay, hence such individuals may have what? Deficiency of lactase, and mainly as it increases, the activity of lactase is decreasing, and such individuals are unable to tolerate when they will drink milk. Then such individuals can develop lactose intolerance due to the deficiency of lactase. Now, these individuals are unable to digest lactase, rather lactose, unable to digest lactose, rather this lactose will go to the colon and it's fermented by bacteria, and it will form unexpected end products like developing lactic acid and different gulls. This is one of the cause of diarrhea, bloating, and pain around the GI if an individual which have lactase deficient. Now, as a physician, how you will treat Those individuals which have lactase deficient. I'm getting your response. As a physician, individuals who have lactose intolerance, how you will treat them? Yes? Can you hear me? Okay, great. Okay. Okay, other response? I'm waiting for response. Yeah, it's better to give what? Formulated. And the other is, we can give, whenever they want to drink milk, we can give the enzyme lactase as a drug. Okay. The other disaccharides are sucrose, and sucrose is a non-reducing sugar since it has no, it lacks free OH at carbonyl carbon in both glucose as well as fructose. And the sucrose is naturally it is dextro-rotatory. Okay, dextro-rotatory. When it is placed in plane polarized light, it will move the plane polarized to the right directions. And sucrose is named as table sugar and mainly found in sugar canes, which is formed by alpha 1 of OH of glucose reacts with the second carbon OH of fructose. Now the linkage is alpha 1 to alpha. OH is on glucose side, whereas the OH at fructose side is found in beta form. That's why the linkage is alpha beta 1 to linkage. That is why sucrose is a non-reducing sugar. There is no free OH on both carbonyl carbon of glucose as well as fructose. And sucrose is named as invert sugar. Why we say sucrose is named as an invert sugar? Because after hydrolysis, sucrose is changed into glucose plus fructose. And sucrose is, as I mentioned earlier, sucrose is dextro-rotatory. Whereas fructose, after hydrolysis, fructose has high magnitude of levorotatory. Then the over effect will be what? It's levorotatory, that initially the compound is dextrorotatory, after hydrolysis it becomes rotatory. That's why sucrose is named as an invert sugar. But at the same time, after hydrolysis, at the same time, sucrose, after hydrolysis, sucrose, if it is changed into glucose and fructose, as you know, fructose is the sweetest sugar of all monosaccharides. Invert sugar is more sweeter than sucrose. Therefore, we can get this invert sugar in cake and so on. Therefore, invert sugar can act as a sweetening agent. The other is maltose. Maltose is made from by two glucose molecules, and the linkage is alpha 1 for linkage. And maltose is mainly digested by maltase, okay, and baby foods contains maltose since it is easily digested by them. The other is isomaltose, and the isomaltose is a digested product of starch as well as glycogen. And what makes isomaltose differ from that of maltose? In both cases, both of them is formed from two glucose molecules, but the linkage in isomaltose is alpha 1,6, whereas the linkage in maltose is alpha 1,4. The other is lactulose. Okay, the other is lactulose. I mentioned lactulose in the last session. Lactulose can act as an osmotic laxatives, and it is given for chronic constipation individuals. Okay, lactulose is reducing disaccharides, which is made by beta-galactose and beta-fructose. It occurs in plants. It can be prepared by alkaline rearrangement of lactose. Its biomedical importance is that lactulose can have its own therapeutic value, and it can act as smaller laxatives. And it relieves as chronic constipation. Okay. At the same time, this lactulose can be given for individuals who develops hyperammonemia. The treatment of systematic encephalopathy, why we give them lactulose is that lactulose, as you know, it's not digested, rather it's fermented by bacteria, and it can be changed into lactic acid and acetic acid. This irritates our intestine. Then, to neutralize the blood has high amount of ammonia for individuals who develops hepatic encephalopathy. This ammonia from the blood moves to the intestine in order to neutralize it. That relieves what? Hyperammonemia. The other classification of carbohydrates is that it's oligosaccharides, okay? One form of carbohydrates. Oligosaccharides are formed in between 3 up to 10 monosaccharide units. And oligosaccharides may be branched or unbranched, and it's not digested in our body since it has no calorific values. But oligosaccharides are very important since it is part of glycoproteins. As you know, carbohydrates, which is found on the outer leaflet of the plasma membrane, can act as a recognition site for cell-cell communication. Mainly, these oligosaccharides are cell membrane proteins which hold this what? Oligosaccharides. There is no free carbohydrates on the plasma membrane. Either it must be bound with protein or it must bind with what? The lipid. And among different forms of carbohydrates which is found in the plasma membrane, oligosaccharides are the most dominant ones. And these are some of the common examples of oligosaccharides. The other group is polysaccharides. As you know, polysaccharides they are polymer of what? Monosaccharides, which is more than 10. The linkage can be alpha or the linkage can be beta. And we do have two types of polysaccharides. One is homopolysaccharides, the other is heteropolysaccharides. Homopolysaccharides are exclusively made from what? One form of or one type of simple sugars. Whereas heteropolysaccharides are polysaccharides which is made from more than one simple sugars. Then heteropolysaccharides, when undergoes hydrolysis, we can get what? More than one type of simple sugars. Whereas homopolysaccharides, when undergoes hydrolysis, we will get only one form of or one type of simple sugars. Homopolysaccharides can be glucosan or can be named as fructosan. When we say fructosan, the simple sugar or the monomeric unit is fructose. Whereas when we named it glucosans, the simple sugars which act as a repeating or building block to form homopolysaccharides should be what? Glucose. Example, starch, glycogen, cellulose, dextrin, dextran, and so on. The best example for fructosan is inulin. Now let's see one by one. Homopolysaccharides, starch. As you know, starch is the main storage form of glucose in plants. And starch polysaccharides has two parts. One is amylose and the other is amylopectin, which is exclusively made from alpha G glucose. This is the structures of starch. As I mentioned earlier, some part of it, almost less than 20 part of the starch is formed by alpha-1,4 straight chain of glucose. That is called amylose. Whereas 80% of starch, okay, is branched part that is made by alpha-1,4 plus alpha-1,6. That is called amylopectin. It accounts 80% of them, whereas 20% and less than that is named as amylose, which is straight chain. And in the case of amylopectin, this is a branched part of starch. There will have what? One branch after 12, 15 residue of glucose molecules. That means there will have what? One alpha-1,6 glycosidic branch point after 15 residue of glucose. Where starch is found, can get from plants. Biomedical importance of starch. Starch is storage form of glucose, and it is a reservoir of energy for plants. And for us, starch we can get from the food what we eat, and it has high as well as caloric values. Where it is starch digested, starch digestion starts from the mouse. After hydrolysis, we can get large amount of glucose. The other homopolysaccharide is glycogen. Now, glycogen sometimes called amylopectin of starch. Glycogen sometimes called amylopectin of starch. It is highly branched than amylopectin of starch. Just like that of amylopectin of starch, glycogen also is exclusively made by alpha G glucose, and there is alpha-1,4 linkage as well as alpha-1,6. But the presence of alpha-1,6 is more common than amylopectin of starch. Glycogen is more branched. Whenever it is more branched, it is easily hydrolyzed whenever our body needs it, especially at early fasting stage as well as in between meals. And it is animal storage form of carbohydrates, which is stored in our liver and skeleton or in muscles. Non-veg diet is a source of dietary glycogen, as you know. And glycogen is more branched than amylopectin of starch. More branch permits enzymes to break easily when glucose is used for our cells, especially in between meals and early fasting stage. After a well-fed state, when we have excess glucose, this glucose can be condensed to form glycogen. This process is called glycogenesis. Glycogenesis is the process of formation of glycogen from glucose, and this is a rate of glycogen synthesis which occurs in the liver as well as in our muscles. But at early fasting stage and in between meals, okay, after dinner and before breakfast, there will have what? Always degradation of glycogen in order to maintain our blood glucose. Then those glycogen which is stored in the liver are degraded to maintain our blood glucose levels. Whereas muscle glycogen, it can degrade, but it uses for themselves. Muscle glycogen will not maintain our blood glucose levels. This is due to lack of an enzyme called glucose-6-phosphatase. Muscle lacks glucose-6-phosphatase, whereas liver has it. And when glycogen is degraded, the end product will be glucose-6-phosphate in muscle, whereas in liver, this glucose-6-phosphate is changed into glucose by an enzyme called glucose-6-phosphatase. This is what I mentioned. glycogen is useful in between, in fasting stage as well as in between meals. Just like that of starch, can be digested by alpha amylase, and liver glycogenolysis, that is degradation of glycogen in the liver, can regulate blood glucose levels at fasting stage, whereas muscle glycogen undergoes glycogenolysis, but it gives energy for themselves, not useful to regulate blood glucose levels. The other cellulose, this is a linear chain of glucose residues, which is linked beta 1,4. Here the linkage is not as alpha, rather it is beta type. And as you know, human beings lacks the enzyme cellulase to digest cellulose. Then it is considered as rapid or fibers. Initially, when you see the function of carbohydrates, all carbohydrates of them is not digested. This form of carbohydrates are called fibers. Among them is cellulose. So our body lacks what? An enzyme which enables to digest alpha and beta for linkage of glucose. And it is this cellulose where it is found. It's found exclusively present in plant cell walls. What is the biomedical importance of cellulose? It provides structural and mechanical support for them. For us, dietary cellulose is not digested and it's not absorbed due to the absence of enzyme cellulase, and hence it will not have no calorific value. Therefore, cellulose is considered as dietary fibers. But dietary fibers has great role for our health. It enhances fecal mass formation. It helps in forming soft and bulky face. It increases intraluminal pressure. That means it reduces what? The transit time of feces to remain in diet. That means it reduces, if for example, if there is carcinogen, okay, if there is carcinogen, if this carcinogen, if it remains in the gut for a long period of time, it will cause what? It may affect our gut, and it increases what? The incidence of different cancers. But if someone eats enough amount of fibers, these fibers reduce the transit time of feces to remain in the gut and eliminates daily as well as metabolic or toxins out of the body through the feces. But if someone takes excess amount of cellulose, okay, it may decrease the absorption of some minerals. That is some of the drawbacks of intaking high amount of fibers. The other advantage of taking fibers in general is it prevents constipation. It prevents constipation, and it reduces the risk of some cancers as well. Just like other dietary fibers, cellulose also reduces the absorption of glucose. That is good for game patients to manage their blood glucose levels. At the same time, cellulose also, or dietary fibers also good to reduce blood cholesterol levels. How? What are the mechanisms? How cholesterol reduce? How cellulose reduces blood cholesterol levels? This is good to prevent or to lower the risk of atherosclerosis. Okay. How cellulose or how taking good amount of dietary fibers reduce our blood cholesterol? What's the mechanism? The mechanism is that taking enough amount of dietary fibers enhances the excretion of large amount of bile acids from our body. As you know, bile acids or bile salts are made from what? Cholesterol in the liver. Later, these bile acids are stored in gallbladder. But bile acids or bile salts, almost 95% is recycled in our body, and less than 5% is eliminated. But taking high amount of dietary fibers enhance the excretion of high amount of bile salts from our body. Then indirectly, bile salts are needed for emulsification of lipids. Without bile acids, lipid digestion is not complete. Then bile acid is crucial for lipid digestion. To do so, this bile acid, which is eliminated from our bodies by the help of dietary fibers, must be what? Made and must be synthesized from cholesterol. Now, cholesterol is substrate and the product is bile acid. Bile acid, the product is eliminated through the feces. To maintain it, it should be synthesized from cholesterol. Now, in that way, blood cholesterol levels becomes what? Decrease. And taking enough amount of or good amount of dietary fibers reduce our blood cholesterol level. That decrease the chance of getting atherosclerosis or heart disease. And cellulose also has, or dietary fibers has high static value. Okay, high static value. You may feel you are taking high amount or enough amount of food. Then this is good for you to manage your body weight, and it is advisable to take good amount of dietary fibers to manage obesity. Therefore, it is better to take good amount of fibers daily in order to maintain our health. This is how fibers reduce constipation, and this is the mechanisms how dietary fibers reduce cholesterol. Now, cholesterol is substrate, and the product is bile acid. Bile acid is useful for emulsification of lipids. Now, bile acids, where it is made? It is made in the liver from cholesterol. And bile salts, it is excreted through the feces less than 5%, normal. Almost 95% is recycled. But if you take high amount of fibers, excretion of bile salts its amount will be increased. Whenever it's increased, less than 95% is recycled. That means we need to have water. Again, production of bile salts. How? It will be formed from cholesterol. In that way, it decreases what? Serum cholesterol levels. That is good for our health as well. The other polysaccharides is dextrin. Okay, dextrin. This is an intermediate hydrolytic product of starch. But unlike starch, dextrin is less complex. Where it is found? Mainly, it is found in manufactured foods, which is given for infants. Why? Because the mucilage nature, that is sticky nature, which is used to bind, and the adhesive agent, which is useful for production of infants' food. The other is dextran. Okay, first one is dextrin, and this is dextran. Dextran is a bacterial homopolysaccharide, which is made from glucose. Where it is found, as I mentioned earlier, it is found in bacteria. But what's the biomedical importance of dextran? Dextran solution is high molecular weight, and viscous solutions with high osmotic pressure equivalent to that of our plasma albumin. Therefore, dextran maintains blood volume and osmotic pressure. The other is 𝒂𝒄𝒃𝒐𝒉𝒚𝒅𝒂𝒂𝒕. 𝒂𝒄𝒃𝒂𝒃 is a modified form of dextran, which is useful as in chromatographic separations. Okay. The other is fructosan. Fructosan is nothing but it is a homopolysaccharide which is exclusively made from what? more than 10 repeating of fructose. The best example here is inulin. Okay, inulin is named as diagnostic carbohydrate, or inulin is useful as part of kidney function test. In our country, in nowadays, kidney failure is increasing. What is the reason why kidney failure is increasing in our country? I'm waiting your response. Why kidney failure is increasing in our country? Yes. Why kidney failure is increasing? Clinically, can you hear me? Okay. 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 Clinically, in nowadays, okay, to check whether our kidney is normal or not, one of the kidney function tests is creatinine. Clinical applicable biochemical test is creatinine, and creatinine, when creatinine level is increasing, creatinine level is increased, almost 50% of our nephrons are damaged. You know, nephrons are this functional unit of our kidney. But creatinine, its amount will increase. Almost 50% of our nephrons are damaged. Therefore, there is no good biomarkers to indicate small injury of our kidney. That enhance what? Kidney failure. There is no early biomarker, okay, to indicate small injury of our kidneys. And the other is in soft drinks, for example, okay, in soft drinks, is preservatives, okay. In our country, in developed countries, there is a rule in the regulations of amount of preservatives which is added on it. But in our country, there is no rule and regulations of how much amount of preservatives are added in soft drinks. That also affects our kidney. And inulin is one of the diagnosis of kidney function test, mainly the GFR, okay, glomerular filtration rate of the kidneys. And inulin is formed from beta-D-fructose. Where it's found, it's present in plants, okay. Inulin is not digested in our body, and it's not again absorbed in our body. That makes suitable to check the GFR, okay. The other group of polysaccharides are heteropolysaccharides, okay. Heteropolysaccharides, as I mentioned earlier, which is made from what? More than one type of simple sugars. It is a repeating. The monomer here is disaccharide units. Okay, the monomer here is disaccharide units. That means when heteropolysaccharides are hydrolyzed, it will form what? It will form more than one simple sugars. And heteropolysaccharides in our body is named as glucosaminoglycans or GAGs. And these GAGs are highly negatively charged molecules. And mainly these carbohydrates can be found by associated with proteins. If the amount of protein is small, this protein is we can say it protein moiety, and the compound becomes proteoglycans. That means here in proteoglycans, the amount of carbohydrate is more than 95%, whereas if the amount of carbohydrate is very small and the protein part is dominant, we call it glycoproteins. Primarily, it's proteins, but small amount of carbohydrates can be present. Now, we do have some examples of GAGs or mucopolysaccharides. One is acidic non-sulfated mucopolysaccharides, that is especially high hyaluronic acids, and the other group is acidic sulfated GAGs. That means, as I mentioned earlier, one of the derivative or one of the derived simple sugars is that amino sugars. Instead of OH, OH is replaced by what? Amine group that makes amino sugars. Now, on this amine group, again, this amine group becomes what? Acetylated. Or it can be what? Sulfated. Now, some of them has sulfate group added on it. Some of them lacks on it or devoid of it. One example is high hyaluronic acids. This is devoid of sulfate. There is no sulfate group on these heteropolysaccharides, whereas the rest is sulfated. And the other group is natural GAGs. These are nothing but blood group substance. Plant heteropolysaccharides like agar, pectin, lignin, gum, all of these are plant heteropolysaccharides. But here, it is made by what? A repeating unit of disaccharides. The disaccharides can be acidic sugar and amino sugars. The amino sugar either can be N-acetyl galactosamine or N-acetyl glucosamine. The amine group, again, it may be what? Sulfated at carbon number 4 and 6. And the acidic sugar is D-glucouronic acids, or it's 5-pimer L-hydrouronic acids. Here, what's expected from you is that, okay, when you read GAGs, what's expected is that where these cards are found and what is its main role on that occurrence, and what makes odd from the others, what makes odd from the others, or what makes unique from the other group of GAGs. For example, keratin sulfate. Okay, keratin sulfate is exceptional here, in which galactose is present rather than acidic sugar. There is no acidic sugar present in keratin sulfate. Rather, it will be galactose. Which is a repeating sequence of heteropolysaccharides, which is exclusively made by acidic sugar and amine sugar. The amine sugar may be acetylated. And here most GAGs are present extracellularly, except heparin. Okay, heparin is not found extracellular. It's intracellular heteropolysaccharides. This makes heparin is unique from the rest GAGs. And most of them can have its own role as a lubricant. Hence, it holds large amount of water. These are some of the functions of glucosaminoglycans. For example, as I mentioned earlier, most of them is found in extracellular matrix, and some of them facilitates what? Cell migration. Therefore, if you consider, for example, cancer cells specifically synthesize what? Specific glucosaminoglycans in order to enhance what? Cell migration, or in order to make metastasize. Cancer cells can synthesize specific glucosaminoglycans. Some glucosaminoglycans are useful for corneal transparency, and heparin, this is the natural anticoagulant. Okay, heparin is the natural which is found in our body. These are some of the GAGs. Okay, Heparin, for example, the last one, it is an anticoagulant, and it's also very important for clearing lipids in our blood. And the other is keratan sulfate. It keeps cornea transparent. And the other is hyaluronic acids. It is useful as a lubricant and shock absorbent in joints. And this is what this is mentioned and listed one by one. Okay, let's see roughly. Okay, we don't have time. Let's see roughly. For example, hyaluronic acids. The repeating units are listed here, and where it is found. Okay. Where it is found. It's found in synovial fluids and vitreous humor of our eyes, and it can act as a lubricant and shock absorbent. And what makes unique here? Hyaluronic acid is found around the ovum. This gives protection to the egg. It has also a role in cell migration during morphogenesis. This is occur in normal development. Therefore, if a given cancer cell synthesize large amount of hyaluronic acid, it helps to them from one part of our organ to the other. But sperm cells, as you know, sperm cells has hyaluronidase enzyme, which can able to hydrolyze hyaluronic acid, which covers what? The ovum. That enhances the penetration as well as fertilization due to the presence of the enzyme called hyaluronidase in sperm cells. Snake venoms, okay, snake has this enzyme also, and it penetrates what? The extracellular space of our body. If one is bitten by snake, and this is how snake affects our body. The other is heparin. This is the most acidic sulfated gas, and their repeating units are listed here, and it has extended helical formations, and it is found in granules of mast cells. Okay, where this heparin is found, it is found in granules of mast cells, and it's highly sulfated. And heparin is natural anticoagulant, and it prevents intravascular blood coagulation by inhibiting clot formation through the interaction of a protein called antithrombin. And heparin, as I mentioned earlier, heparin acts as an anticoagulant. Besides that, heparin also useful to clear what? Lipids in our blood. How? Initially, we do have an enzyme called lipoprotein lipase, and this lipoprotein lipase enzyme binds with heparin sulfate in the capillary. The presence of heparin displaces lipoprotein lipase from heparin sulfate. Now, once lipoprotein lipase is free from heparin sulfate, it can do their own function by clearing triacylglycerols from the blood. Hence, its role is what? To break triacylglycerol to form glycerol and free fatty acids. These are some of the therapeutic use of heparin. Okay, heparin can be injected for those patients who have myocardial infarct. Heparin can be given for them since it can liquefy their blood and it can prevent blood clotting, and it can clear what? Lipids from the blood. The other is heparin sulfate. Okay, this is acid sulfated gas. It has repeating monomeric disaccharide repeating units. And the other, what's the function of heparin sulfate? Heparin sulfate is mainly found on the receptors, okay, which is found on the plasma membrane, okay, and it can act as a receptor. Now, this heparin sulfate are useful for our cell growth, for our cell addition, and cell-cell communication. As you know, cancer cells are unable to, once or cancer cells can avoid what? Cell addition. Okay. Therefore, whenever there is cancer cells synthesize or decrease what? The synthesis of heparin sulfate for the benefit of them, not for the benefit of the organ. And the other heparin sulfate is found in basement membrane of our kidneys. This helps to determine charge selectivity of our GF, glomerular filtration. The other is chondroitin sulfate. Where it is found? It's found in connective tissue of bones, cartilage, and tendons. It gives strength to them. It's also found in cornea and gives the overall shape of our eyes. And the other is dermatin sulfate. Compound, from the name indicates, it compound in the skin, compound also in the blood vessels and heart valves. It gives mechanical strength to them. But dermatin sulfate also plays structural role in sclera of our eyes. The other one is keratin sulfate. What makes keratin sulfate is unique from the others? Instead of acidic sugar, it has what? Galactose. It has galactose. This makes keratin sulfate is unique from other GAGs. It's found in cartilage, aorta valves, and it gives structure and support to them. It also present in cornea and lens of our eyes. And it gives what? Our lens becomes transparent, and it gives also shape of our eyes. Other blood group substance. These are neutral GAGs, and it's present on the cell surface of our red blood cells. What are the components of blood group substance? The components are like galactose, fructose, N-acetyl galactosamine, and N-acetyl glucosamine. And blood group substance are nothing but they are glycolipids. That means we do have carbohydrate residue which is bind on it on the surface of red blood cells, and the component of carbohydrates can determine our blood groups. Some carbohydrate moiety can be added on its antigen, and the presence of the antigen individual belongs to that group. If an individual which have A antigen, it belongs to what? Blood group A. If an individual which have antigen B on red blood cells, it belongs to blood group B. If an individual which has both A and B antigen on red blood cells, it belongs to what? Blood group AB. An individual which lacks both A and B antigen on red blood cells, it belongs to blood group O. Now, the presence or absence of this antigen is dependent on what? The presence or absence of small amount of carbohydrate moiety that determine our blood groups. What is the why we study GAGs, or why we study glycosaminoglycans on aging or during different pathogenesis? The amount of synthesis of these GAGs may be increasing or decreasing. That indicates the manifestation of specific diseases. For example, in tumor cells, it increases what? The synthesis of hyaluronic acids. Because cancer cells want to migrate from one part to the other to undergo metastasis. It synthesizes what? High amount of hyaluronic acids. At the same time, it decreases what? The synthesis of heparin sulfate in order to reduce cell addition. Okay. Can you hear me? Let's give. Can you hear me? And 15 دقيقة شارفت. Okay, after 15 minutes, we'll start the next part, lipids. Now it's tea break time.